Okay, welcome to day 3 still of Leetcode 75. We're doing move zeros, which is 283. So we're given an integer array of nums. We have to move all zeros to the end of it while maintaining the relative order of the non-zero elements. We have to do this in place without making a copy of the array. So basically we just move every single zero to the end while maintaining this relative order right here, 1 through 12. And we also have to take into account of maybe like a zeros list or something like that. We have to make sure we can minimize the total number of operations done as well. So this points me to like a 2-pointer solution. So technically, so we can see how that's applicable here. So say we have 2 pointers, I, and we have j as well, right? So we want to have one slow pointer and one fast pointer, we can kind of call it. So like essentially both of them are set here. So every time that since we need to do this in place as well, lists are mutable within Python by nature. So essentially what we have to do is every time we go through the array, we need to be able to essentially remove this out of the list, bring this all back to here, and append it back to the end of the list. All right, and then when we do that, we need to move this pointer up. This pointer stays here, and we're gonna do this until this pointer gets to the end of the list. If we see that the current position is not a 0, then we can move both of the pointers up. So we see that we have a 1, so we can go ahead and move both of them up here. Then we have a 0 on I, so we need to check where I is and if that value is a 0. So we go ahead, move this out, all these values come in, append at the end of the list, move j up, and we see that I is going to be equal to not a non-zero. Move that up, move j up, and then we can move I once again. We move I up to the 0, and we move j out of the list. So j is going to be used as a determining point between I guess like the number of zeros that we have, essentially. So it moves us out of the list so that we don't accidentally modify the portion of the list that have the zeros. So let's go ahead and implement the solution then. So we move j, then basically the entire times that we see any given time we will move j. Essentially, we will always move j in the array, but for I we only move it when we don't see a 0. Yeah. Because we want to be sure that we can move all of the non-zero elements to the front of the list while moving all of the 0 elements to the back of the list. So let's go ahead and try to implement this. So we have j is equal to 0 and 0. We're going to say while j is less than the length of nums, if nums at I is equal to 0, then what we're going to do is we're going to pop it at I for nums, and then we're going to append 0 at the back of the list. We're going to move j up so that we're basically telling ourselves like, hey, every time j will move. Otherwise, if nums is non-zero, then we'll just move I up. Because what we're going to have, essentially what we said again, I is going to be the one that's trying to find all the zeros. It's going to mark its place like, okay, this was a 0, and then j is always going to be just moving up so that we don't accidentally collide with we don't have, to the point where we want to prevent I from going to the section that has all the zeros. Let's go ahead and run. Oh, sorry, I need to actually, I don't have to return anything actually. It's not return type. So that's going to pass those 2 cases, and that should pass the rest of the test case there. And yeah, that's the solution to move zeros.